This is the second example to determine the mobility of the mechanism. The picture shows a real mechanism being used in the packaging line for folding the boxes. In order to determine the mobility of this mechanism, the first step is to study the mechanism. For this one, first we are going to find out the stationary links or the frame. As you can see that these are the 2 points that mechanism are connected to the frame or the ground. This is a rotating link which we call it crank. Usually in the real machines it represents a motor. These two are two sliding joints that fold the box and driven by two links. The second step is to draw the kinematics diagram of this machine. A kinematic diagram is a scale drawing that only shows the elements important to the motion of the machine. First step is to find where are the proper points for the ground and where this mechanism is connected to the frame, and these are these 2 points. Next is the crank, which in the real machine shown by a disc, but in the kinematics diagram is a simple links which connecting being shown with a line with 2 nodes. This is a triangle link with 3 nodes that connected to the ground, and this link connecting this triangle node to the crank. These 2 links connecting the triangle link to the slider and 2 sliders which basically in the real mechanism folding the box. This is a kinematic diagram of the system, which is simplified and shown by the schematic symbols. The next step is to identify the number of the links. The first link is frame, and we are going to count it as a link number 1. Link 2 is the crank. Link 3, link 4 is a triangle link with 3 nodes. Link 5 is connecting this triangle to the slider, and link 6 is connecting to the other slider. Link 7 is the slider itself, and link 8 is the other slider. So the total number of the links are 8. The next step is to find out the number of the joints and determine if we have any half joints or full joints. This is the full joint, a pinpoint that's connecting the triangle link to the ground. Joint number 2 also is a full joint connecting the triangle link to the coupler. Joint 3, coupler to the crank. Joint 4, pin down of the crank to the frame, and also it is a full joint. Joint 5 is a pin joint. Joint 6 is a slider, and it's going to be counted as the full joint. Joint 7, joint 8 is the other slider joint. This joint connecting 3 different links together. So as we mentioned before, we are going to count this as 2 joints, and both of them are the full joints. So joint number 9 and joint number 10. So the total number of the joints are 10. The next step is to determine the mobility of the system. In order to use determine the mobility of the mechanism, we use the Grubler formula. And since we have 8 links in this mechanism and 10 full joints, and we do not have any half joints, the number of the mobility of this mechanism is 1. It means that we need only 1 input to control this mechanism, and usually for this mechanism is a motor.